We've got an oblique surface, an inclined surface, and some regular vertical and horizontal surfaces as well. So starting this drawing from scratch, the very first thing I'm going to do is actually draw my bounding boxes based on the measurements of the isometric drawing. The depth in the X direction is 5, so that's going to be the width of the right-hand view and the height of the top view right across the miter line. The Y direction dimension is also 5. That's going to be the length of the front view and length of the top view. And then the height, the maximum height is going to be that back corner. So I'm actually going to sort of draw a square for the base so I can measure straight upwards from that hidden back corner. And see, the height is also 5, which means that all of my front, top, and right side views are all just going to be squares. So electronically, I've scaled my graph paper so that one square on the isometric drawing is going to be one square on my orthographic drawings. If you're using paper graph paper, that usually won't be possible, and you'll have to actually multiply or divide to make it the right size so that it fits. But that's why you draw the bounding boxes first, to make sure that you don't actually start making your drawing and get halfway done and realize that you made it way too small or way too big or way off center or something like that. Your first instinct is going to be to draw the vertical and horizontal sections first, but try to fight that. When you have an oblique surface, you're going to be able to see that surface from all 3 directions. Draw that one first. That's why you define your XYZ coordinate system, so you have a common point of reference, and you just need to find the XYZ coordinates of each point of the oblique surface, plot the points, connect the dots. Point A, super easy, 0, 0, 2. It's at 0, 0 in the XY direction, and then just straight up 2. Point B is still on the front surface, so X of 0, but it's all the way on the left-hand side, so Y of 5, and up just a height of 1, so Z equals 1. Now point C is kind of difficult to actually see exactly where it is. Again, it's kind of set inwards a little bit, but it's not immediately obvious exactly how far. Whenever you have something kind of like this, draw yourself a full glass box with the origin at one corner of your box and your point at the opposite corner of the box. And by following just the isometric grid lines, you can draw yourself a box, and it'll make it much easier to see exactly where that point is located. Because sometimes looking from an isometric view, things are sometimes a little deceiving as to exactly how far in they are, like whether something is really high or just really far back. Sometimes you can't always tell. But drawing the glass box really helps you actually just measure the distances in each of the 3 directions. And in this case, we get an X value of 1, a Y value of 3, and then a Z value of 2. And that Z value of 2 makes sense in that it's on that same flat horizontal surface as point A was on. So plot all 3 points on front view, top view, and right side view. Connect all the dots, and you end up with 3 triangles that represent the view of this oblique face from all 3 different orthographic views. And from there, the rest of the drawing isn't necessarily easy, but it's manageable. I'll start off by drawing the front view first. So on the front view, the very bottom of the front view is a vertical face, kind of a trapezoid. You can just darken that in since you already have the diagonal line drawn. Right above the oblique face, you can see a square shape. And then the last thing that's going to be visible is that slanted surface that's kind of L-shaped. But since you already have the square drawn and you already have the triangle drawn, the oblique surface down at the bottom, that L-shaped angled surface just kind of fits in right around them. Top right-hand side is going to remain empty. That's an actual rectangular hole, rectangular cutout that passes all the way through. There's no material there, so the drawing will be totally empty. And from this direction, you can see that there's no hidden lines. Everything would be visible from looking from this angle. Let's shift over to the right side view, where again, there's a rectangular flat surface on the bottom of the right side view, but it right up to the right. And I'll go ahead and draw that in first. And that actually shows me something interesting. The oblique surface here is actually going to be drawn as a hidden line, not a visible line. When looking from the right-hand side, the oblique surface is kind of tucked in underneath that front block wall. So I erase the diagonal line that I drew here and redraw that as a hidden line. Keep working my way from right to left, and I see this 5-sided shape over on the sort of backhand side. And then a little bit further to the left than that, there's this small triangle in between that's sort of gonna finish the slope from that 5-sided shape to the oblique surface that I drew kind of at the beginning, the diagonal line. Now the top left of this view, again, this is just gonna be empty space. Looking at the isometric view, you can see that there's just a big empty cutout there. There's no other material, so I'm putting the word empty in here, but I'm gonna erase that later, but I write it there for now just so that I know that I'm kind of done with this section, so I can move on and not worry that I forgot something. So jumping up to the top view, I've got a rectangular surface all the way on the very top, and so I'll draw that rectangle first. Working my way down, I'm gonna skip the slanted surface and do that last. Instead, I'll draw the flat section next. And since I drew the oblique surface first, that diagonal line is already there for me to use. So as I draw this slanted surface, basically since I'm drawing it last, I'm just sort of connecting the dots. The shape is almost already entirely drawn. If you want more practice drawing slanted surfaces like this L shape here, I've got a video on that also, so you can watch 2 example problems where the main emphasis of the problem are these sort of angled, slanted, diagonal type of surfaces. So one last check that there shouldn't be any hidden lines anywhere, and looking at the isometric drawing, nothing should be hidden or obscured besides that one sort of tucked in little tiny diagonal line. So just erase anything that needs erasing. And we're done. But one thing that never gets any easier is trying to draw circles and cylinders by hand. That is always going to be difficult, and so if you want some practice problems on how to draw orthographic cylinders and holes and circles, then that's the video that's linked up on the screen now.